Hi folks, this is Karim Raouf for IT Visualizer channel. We will continue our lab, the matrix labs, the video number 137. We have been discussing in the previous video the following. We are still working with troubleshooting Windows using Microsoft Sysinternals suite. We are still working with the cases created by Claude 3.7 Sonnet. These cases, as we have seen so far, are very useful. These are real world examples or case scenarios that was solved using Microsoft Sys internal suite. We have stopped the last time at case number 23, the hanging PayPal emails. Okay, Maya, this is the junior IT, and then we have Leo, the senior IT. This user noticed that whenever they open an email from PayPal in Outlook, the application would freeze for up to a minute before displaying the email. I think maybe the email contains some data that need to be downloaded from the internet, maybe in its body. Let me check and see, maybe this is something else. Let's use process monitor to see what's happening during the delay. They capture a trace while opening a PayPal email. It took too long running operations to make long running operations easier to spot. Let's add the duration column to the process monitor. We can do that. This column shows how long each operation took. Let's try to open process monitor and see if we can have an option like that. So this is it. Let's do this, and then we have sys internal suite, and then we have process monitor. Here you go, and then run as, and then we have the filtering. So now we will see a lot of operations, and we can add a column here. Let's select column. We have something called duration. Where is the duration? Here, duration. So now we have another column. Okay, we can stop capturing. Now we can see each operation, how much time it took. I think this is in maybe in milliseconds. Yes, I think this is in milliseconds. Anyway, let's see or continue the scenario. We can also set up highlighting for events that took longer than 1 second. This makes the slow operation really stand out. This is very simple. We can just filter this one, and we can ask longer than 1 second because these are in milliseconds. So if you go to duration, where is duration? Here is duration is or equal maybe less than or more than uh, uh, more than, let me see, here is talking about more than 1. Okay, let's see if this can be there. Apply. We don't see anything like that, but anyway, this is a way to do that. We can filter it by seconds. Okay, again we can filter, reset the filter, and now we can see here all of the operations. For example, we can make them by the, okay, there is a one which have 4. What is this? We have 4 point. So why it didn't give me this one? It's 4 seconds. Let's try to see how the filter will work. Now we say that highlight events that longer than 1 second. This makes slow operation. So I think we need to highlight. He's talking about highlight. Okay, let's go to duration again. Less contains is not more than, how we can do that. More than 1. Okay, and then add. Let's see how this will go. So that's it. Okay, we can see now that we have 1.4 millisecond. I think this is a new operation. I didn't pop up before because this is a new one. So we can see we have more than 1 second. We have only one operation that took about 4 seconds. Let me see what is this. This is search indexer. Okay, I think this is related to control, read, use, and journal. This is related to the use and journal. Okay, so we can see here that this operation take about 4 seconds. Okay, so we can go again and reset the filter. So now we have everything now again. Now uh, we can also highlight the 1 second. Let's Leo sets the rule. Point exact. Look at the highlighted event. A create file operation took over 2.6 seconds trying to access a path called so and getting access denied. So interesting. The server names look like an IP address, but one of the zeros is actually the letter O. So this is strange how this goes. Let's check the HTML source of the email. So as I suspected, there is in the body of the email there is an HTML, or there is some HTML source in the body of the email. So it's trying to download something in the body of the email from a certain website. They examine the email source code. Here it is. The email contains an img tag with a URL starting with instead of HP. So to this email, there is a body in the email. Try to download a certain image from the internet. What does this mean? In web pages, a URL starting with this uses the same protocol as the current page. For example, if our an HTTPS example.com becomes HTTPS example.com, but in an email viewed in Outlook, there is no protocol to copy, so it's tried to interpret it as a UNC file path, like a network share, and times out trying to connect. So there is a problem trying to connect to download a certain uh, image. Okay, so PayPal email template has a bug that causes Outlook to freeze. There are two issues. PayPal email templates is using an invalid URL format, and Outlook picture download blocking isn't properly blocking this type of reference. And Outlook picture download blocking isn't properly blocking this type of reference. How do we fix it? As a workaround, you can block the domain in your host file. So he will block. And again, what does this mean? It will not go and download the website. It will just stop. What does that do? It redirects any attempts to connect to the domain to that domain to the local machine instead, causing the connection to fail immediately rather than timing out after a long delay. That's clever. So it fails, but fails quickly instead of slow. So I think the problem was the IP address of the PayPal website. Maybe this is it. So it's interpreting it wrong. This should be 0, not O. So he's saying that the issue here is using an invalid URL format. So this URL is not typed correctly. Okay, PayPal redirect or redirecting to a wrong IP address, or this is not valid anymore, or it is typed wrong. They send him an email that uh, downloads an image that is pointed to a wrong server. Okay, this is not the correct IP address. So they will just put in the host if the local host, or you can, I think we can do this using in a domain. If you have DNS, you can uh, correct it, for example. But I think this is not the best way. Is to uh, take the local host file and use it. Okay, so that's clever. So it still fails, but fails quickly instead of slow. Microsoft eventually fixed this issue on Office 2010 Service Pack 2, closing the hole in the automatic picture download blocking. Okay, so This is simple. As far as I suspected, it was a correct guess. It is a problem with the body of the email that is trying to download a picture that is not there anymore in a website that is not typed correctly. Okay, so this is one case. Can I take it and okay, let me do something. I need to take it and ask Grok to explain it simpler in simple terms, even though this seems to be simple enough, but I need to ask Grok to explain it. So we will take this one, copy, and let's try to give it to Grok and put the thing, explain this case in layman's terms and include glossary for terminologies. Okay, let's see how this will work. Now you have the case as a whole, and then try to put it like that, and then let's see how this will be solved. You can copy that and go to Gemini, the same one, with the same prompt, and go to ChatGPT and see the same prompt and see how this will go. But I think we can go to reasoning, which is better. And we can go like that and go like this. So let's see. So let's see the case. Okay, imagine Maya, a regular person using her computer, opening an email from PayPal and Microsoft Outlook, the program she uses for emails. Every time she does this, Outlook freezes up to a minute before the email finally shows up. That's super annoying, right? So her friend Leo, who know a bit about technical stuff, steps in to figure out what's going wrong. Leo suggests using a tool called Process Monitor, which is like a detective for your computer. It watches everything the computer is doing, like opening files or connecting to the internet, and writes all down. They run this tool while Maya open one of those tricky PayPal emails to watch the problem in action. To make it easier, Leo adds a duration column to Process Monitor. This is like adding a stopwatch to the detective notes, showing how long each task takes. He also sets it up to highlight any task that takes longer than 1 second, kind of like putting a big red flag on anything slow so they can spot it quickly. While working or while looking to these results, Maya noticed something. A task called create file operation is highlighted because it took over 2.6 seconds. This task was trying to reach a weird address, okay, but it failed with an error saying access denied. It's like the computer tried to knock on a door that doesn't exist and got told no entry. Leo takes a closer look, says that address look like an IP address. You know that the numbers computer used to find each other online, like so and so, but wait, one of those zeros is actually a letter O. That's clue something fishy. Okay, they dig deeper by checking the HTML source code of the PayPal email, the hidden instructions that tell the email how to look. Okay, so this is an email in an HTML format. Okay, there they find an M tag, which is a command to load a picture, but its web address start with that instead of HTTP. So it didn't redirect it to a certain. So you need to put the protocol that will connect to the website and download the page. So it is not there. Okay, normally this means use. So this only is put when you are on a local share. Okay, you put only those and type the IP of the local share server, and then you can access. But if you go into the internet, you need to have HTTP before those two. Normally this means use whatever method the page is already using to connect. But an email program like Outlook, this can confuse things. Again, this is not told by Grok. You need to identify the protocol to connect and download the image. This was not said. By putting this only without HTTP or HTTPS, that means that it is connecting to a local server, which was not the case. Okay. Here is what's happening. Outlook sees this picture link with the funny and the typo like O instead of 0 and tries to find a server that doesn't exist, like sending a letter to a made-up address. And actually it's trying to search internally, which is not there. He will not try to go outside. It keeps trying for a while, getting access denied, and that's why it freezes for almost a minute before giving up and showing the email. In short, Outlook was freezing because the PayPal email had a broken link to a picture. That's it. Caused by a tiny mistake in the address. Using Process Monitor, they tracked down the slow spot and figured it out. It was this bad link making Outlook stumble. So that's it. We have all of the HTML source code, the behind the scenes instruction for a web page or email, written in a language called HTML. It's like the blueprint that tells your email how to look and how to show. Okay, so that's it. And image tag, a piece of HTML code that tells the computer to load a picture. It includes a web address pointing to where the picture lives online. That's it. These two actually give us a good picture about the case. Protocol relative URL, a web address that starts with this instead of this, it's supposed to adjust automatically to match how you are already connected, but it can cause trouble in programs like Outlook that do not handle it well. So again, another info, if you are typing the website without putting HTTP or HTTPS in your browser, it can adjust itself automatically to choose one of them. Okay, but in Outlook this is not the case. And actually, if you do that or you put that, this seems to be like a local IP, not going to the internet. So this is the case, shows how so and so. For example, let me show you what I mean by this. If I type something like that, if you put something like that and put like that, this means this is a local server, okay? But for the internet, you need to put HTTPS, for example, and then put these, okay? So this is the difference between these two. So this is the explanation of Grok, and I see it very, very simple explanation. Actually, it seems to have a point or to have an advantage in explanation. Okay, so okay, investigation, finding the slow step. It was looking there, file cabinet almost. I think the same, maybe it's taking the same or it's typing the same thing that Grok has said. If we go to ChatGPT and let's see its answer. This seems to be more organized. Actually, I think Gemini needs to have some organization in its layout, maybe. What's going on? The simple story. Opening a PayPal email made Outlook hang. Each time the user click on one of those messages, Outlook froze for 30 60 seconds before showing the content. The investigation watched Outlook every move by the process monitor. Once action jumped out, Outlook tried to create open a file or connection to this website. This took 2.6 seconds, far longer than anything else, and ended with access denied. The computer or security software refused the request. With process monitor duration column and brightened up the bright red highlighted rule, showing anything that lasts less or more than 1 second, this slow step was easy to spot. So the catapult was a single invisible image tracking pixel in the HTML email. Notice the O instead of the zeros to trick to disguise a marketing analysis server used by Adobe Omniture tracking. So domain sneaks in letter O instead of 0, a trick to disguise marketing analysis server used by something. So this is a good info. I didn't know this. So begins data protocol. Outlook treats it like a network file path. So this is it instead of a normal web page. The security rules block that network shared style path. Outlook retries, waits, so and so. Fix workaround. Block external images in Outlook or view the images in plain text. That's it. You can change the format of the email, and this happened to me, and I solved it by changing it from HTML email to a plain text email. If you're running mail filtering software, strip or rewrite protocol, links to standard, so does not misrepresent, no one so and so. I think not that good. The best one is Grok from my point of view. As we can see here, this one, a domain used by Adobe Omniture Analytics, the O letter can look like a 0, making it easy to misread. Okay, so this seems to be something. The bottom line, the PayPal emails written weren't malicious, just poorly coded marketing pixels. Outlook froze while trying and failing to fetch that pixel as if it were a local network file. Removing or blocking that one line of HTML stops the freezing instantly. Okay, so this is the case. If we can try to go and see the other cases, let's go and see case number 24, the hanging account software. After upgrading from Windows XP to Windows 7, users found that an old accounting program would hang when they try to use the print feature. Okay, let me guess. It needed administrative rights to print. Um, I think maybe there is a problem with the printer driver. Maybe that's part of it. The administrator found that if they ran the program once by administrative rights, it would then work correctly when run with the standard user rights. So he can print if he have administrative rights. He cannot print without administrative rights. So this seems to be a problem with the permissions of the software. Let's see that. Sounds like need to set something up the first time it runs. This is what we call a run once issue. Many older programs were written before the days of the user account control and expect to have full administrative access to set things up when they run the first time. We all know user account control. That's a simple, or we know this feature. So what's the solution? Give everyone admin rights? No, that would be a security risk. The use process monitor identify exactly what changes the program makes when they run as admin. Then we can make those changes once for everyone. That's a good thinking. We need to see what the program is doing when he run as an admin and try to see when the program what it will do when we are running with a normal user and try to see the difference. Okay, then we capture the program running with admin rights. First, let's filter to show only events from the accounting program its shell processes. We can do that. Now we will filter for category is right to see only operations that modify the system. You need to do only the right feature because this, I think the print need the right feature. Okay, so when you print something you need the right feature or the right to see who is changing the system. We can simply do that by filtering, and then we need to see here where is the right feature. We can see uh, here we need to see the operation. So we tell him operation, this is the operation. Okay, is okay, right. Okay, let's see like this and see if this will do. We do not see right. Okay, let's cancel and filter. Let's reset. I think operation read. So this is read. Let me see, because I think we can filter it now. We can filter and see the operation. I think equal uh, contains or equal is, let's see, read file. Let's see if this will work and apply. We have this read file, okay, or we can tell him there is read only, there is no write. So I think there is no operation here I have as a write. Okay, so anyway, we can just filter and reset, and then we can go again to the case. Where is the write operation? Apply the filter. Look at all those registry write. The program is creating registry entries for something called VS Printer 8, VS Printer 8, and several GUIDs. What are those? It's registering a COM component that is needed for printing. COM, Component Object Model. It's a way for Windows programs to use functionality from other components. The program needs to register this printing component in the registry before it can use it. So it will do a couple of changes in the registry to enable the user to print. How do you fix this for all users? We can create the .reg file with all the registry changes and deploy it to all machines using this software. Leo shows how to extract the registry changes using the process monitor count occurrence feature. So let me see. So here he is getting all of the registry changes by counting them. So for example, if I see here some registry changes, I can count them. Let me see, for example, if I can do this. We have the filter. Where is the count? I remember something doing this before. We have the count occurrence, and then we need to have the operation. Where is the operation? An item to filter that value. So here, for example, we will need to have the operation column, not the column, yes, yes, column of operation. We have it, and we have operation is reg. Okay, let's see that reg and add, apply. Okay, so tell him count. Strange, no, this is not the case. Let me reset the filter. So I remember doing this. First of all, we go to the count occurrence. We need the operation. Double click an item to filter out that value. Okay, so double click an item to filter out its value. Double click on an item to filter on that value. Okay, so what I have done here, let me go. Okay, close. I remember doing that, but I remember how I did that. So operation, we can, I think, remember by doing that. Let me see how we give this up. Tools, count occurrence, and then we have path. So let's see, he's talking about the path. Okay, okay, and then count. Okay, so now you're having the passes. Oh, this gives us the location of the registries. Okay, so here we go, we have the counts, so we can save them, and then we can see the different registries that are modified. Okay, and I think we can have them and then see their value. So here we have this one. This gives us a complete list of the modified registry keys, which can be exported and deployed to other machines. It's like pre-installing the furniture, so the program doesn't have to build itself. So the program only needs those registry changes once, and then it could run fine without admin rights. Exactly, it's a classic run once issue that's common with older software not designed for limit rights environments. So this seems to be a good thing. Here we have already all of the registry keys. Uh, okay, this seems to be good anyway. So let's close and then reset the filter. So now we have everything. Let's try again to take uh, this case and try to explain it with Grok in a simple way again, just to make sure that we have also a good explanation. Even though it seems to be straightforward, but let's see also how this will work. Now we have copy, and then we'll do the same. Let's go to, I think I will mostly depend upon Grok, but before that let me get the same prompt. So we will explain this case using mostly for terminologies. We have copy and then do like that and then do like this and then take the case, copy, and then put it in Grok, and then let's see how this will work. Okay, let's see the explanation of Grok. Imagine you are using an old accounting program on an ancient computer running Windows XP, and it worked perfectly, but you upgrade to a newer computer with Windows 7, and suddenly every time you try to print something from the program, it freezes, like it's stuck in quicksand. That's the problem users faced in this case. Two tech-savvy folks, Leo and Maya, stepped in to figure out why and how to fix it. Leo discovered something interesting. If you run the program just once with extra special permissions called administrative right, it stops freeze and work fine after that, even for regular users who don't have those special permissions. So the trick, this was explained better than Claude here is saying that you only need to run the program once in administrative rights, okay, and then you can run the program after that with normal user permissions and he can print. But if you make the user use the program for the first time, it will not print. You need to run it with administrative rights, okay, for the first time, and then the user can after that try to use it with his account. It will print normally. So it is as if the program needs to unlock a secret door the first time it runs, and opening that door requires a master key. After that, the door stays unlocked and everyone can use it normally. That's the case. But here is the catch. Giving every user the master key admin rights all the time isn't a good idea. Uh, so he's talking about that he ran it for the first time just once with extra stops. Okay, so that's it. By the catch, giving every user the admin rights isn't a good idea, but it's like handing out keys to the whole building if you only need access to their own rooms. Too risky. So instead of doing that, Leo and Maya decided to play detective and find out exactly what the program is doing when it gets the master key. So they used the process monitor, which is a super nosy spy that watch everything the program does and writes it all down in a detailed diary. They ran the program with admin rights and let process monitor keep track of every move it makes. And then they filtered the diary to focus only on the accounting program actions and specifically looking for moments where it was changing something on the computer, like writing new notes or updating settings. When they checked the filtered diary, they saw that the program was busy scribbling a bunch of entries into something called the registry. Think of the registry as a giant filing cabinet where Windows keep all the important instructions and settings for programs. The program was adding notes about something called VS Print 8, and some were called goods. These entries were part of registering a COM component, a fancy term for a helper tool that the program needs to print stuff. It's like the program say, hey Windows, I need this printing gadget, so please set it up for me. Very good explanation. The problem was that setting up this printing gadget requires those special admin rights, which regular users didn't have. That's why the program froze. Without the master key, it couldn't finish the setup. But once setup was done, the gadget was ready, the program could print without the need for this key again. So, how to fix this for everyone without handling our master keys? Leo had a clever idea. Take all those changes the program made to the filing cabinet, the registry, and bundle them into a single instruction sheet called .reg file. The file is like a sheet code. When you run it on a computer, it instantly updates the filing cabinet to all the right setting. They could then send this file to every computer using the accounting software, so the printing gadgets set up for everyone in one go. After that, the program works perfectly for all users, no master key required. In short, the old accounting program was freezing because it needed to set up a printing tool, and the setup demanded extra permissions. By spying on the program with Process Monitor, figuring out what it needed, and creating a .reg file to apply those changes everywhere, Leo and Maya solved the problem safely and efficiently. So we can see here the glossaries, component object module, a helper tool that one program can share with others, like a printing gadget that the accounting software needs. Registering it means telling Windows, hey, this tool is ready to use. GUID, a one-of-a-kind code like a fingerprint used to label specific tools or component in Windows. It makes everything has its own unique tag. Okay, .reg we have seen, user account control, a security feature in Windows that asks for permissions before letting programs make big changes. It's like a guard who checks if you are allowed to do something important. So very good explanation. I think Grok is better in explaining and simplifying than ChatGPT and Gemini. I prefer this explanation. Then we have case 25, the slow keynote demo. Leo, this case comes from technical conference where a presenter was preparing a demo for Windows 7 when he signed a demo application with a code signing certificate. It's suddenly starting taking over a minute to launch. This is strange. Why would signing the application make it slow to start? Let's see what Process Monitor revealed. The presenter captured a trace of the slow application launch and looked for unusual gaps in the timing. They examined Process Monitor trace of the slow application launch. He noticed large gaps in time between events. First, there was a 10-second gap there. They zoom in on the gap in the Process Monitor trace. Before the gap, there are references to networking components. After the gap, there are crypto-related registry operation. This suggests that the application is doing something with the networking and cryptography during that gap. Was it trying to verify the signature online? That's what the presenter suspected. He found several more gaps, about 12 seconds each, all following the same pattern. They look at further gaps in the trace. Each gap begins with a reference to the internet connection setting, followed by crypto operation. How many of those gaps were there? 5 gaps, approximately 12 seconds each, totaling about a minute, matching the observed delay. To confirm the theory, he examined all of the call stacks of those operations. They look at the call stack of an internet setting registry access. The call stack confirmed that .NET framework was checking for certificate revocation through when verify test, which was trying to contact certificate revocation servers on the internet. What certificate revocation? It's like it is something related to seeing the signature of this application, and there was a problem with this. When a digital certificate is compromised or no longer valid, it gets added to a revocation list. Programs check this list to make sure a certificate is still valid, but if you can't reach the server that hosts the file, it often times out after a delay. But if the demo machines weren't connected to the internet during the conference, this could cause timeouts. Okay, that's correct. He was not connected to the internet, so the program could not verify it could not verify it is signed. It need to be before launching. It need to verify that it is signed, or Windows I think need to verify that it is signed. The solution was to create a custom configuration file for the application called disable this check. Okay, so the .NET Frame was trying to validate the code signature causing .NET Frame in Windows. Okay, trying to validate the signature of the program causing delays when it couldn't reach the servers. This is a classic example of seemingly mysterious performance issue that process monitor quickly revealed through its timing information and call stack analysis. It's like noticing that someone keeps leaving the room for 12 minutes at a time and then discovering they are trying to make a phone call in the area with poor reception. So I think this need to be also explained in far more details, or to be explained in simple, to break it to simple, more simpler terms. Let me first go again and take the prompt and try to explain also this case. Okay, so here you go. We have this case. We have to copy it and then put it like that, and then put the whole case again like this. Copy, and then go and Control V, and then we do like this and try to see. So let me close first, or can leave the process monitor. Okay, I have only one query left. It resets every 24 hours. Okay, anyway, let's go and see the explanation. Imagine you are a presenter at a big tech conference ready to show off a new app you have built for Windows 7. You have added a special digital stamp of approval called a code signing certificate to prove your app is safe and legitimate, but when you try to launch it during your demo prep, it takes over 1 minute to start, way too long, especially with an audience waiting. To figure out what's happening, use a cool called process monitor, which is like a super smart detective that watches every move your app makes and writes it all down. When you check the detective notes called the trace, you spot some big delays, like a 10-minute pause here and a bunch of 12 minutes pause there, adding up to a minute of waiting. Okay, digging deeper, you notice something interesting. Right before each delay, your app seems to be trying to talk to the internet. Then after the delay, it's doing some security stuff related to code and locks called cryptography. It looks like your app is trying to double check that its digital stamp is still valid by asking some servers online, a process called certificate revocation checking. Here is what that means. A certificate is like an ID card for your app. It gets stolen. If it gets stolen or goes bad, it ends up on a no good list online. Your app wants to make sure its ID isn't on that list, so it tries to call the server that keeps the list. But there is a problem. Your demo computers at the conference aren't connected to the internet. When the app can't get an answer, it waits and waits, call timeout before giving up, causing those long delays. You confirm this hunch by looking at the app's to-do list, something called stack or call stack. During these pauses, shows that the part of Windows called .NET Frame is using a function named WinVerifyTrust to check the certificate online. Since it isn't connected, you get 5 big delays, each around 12 seconds, totaling about a minute. The fix: they make a small configuration file Think of it as a note to your app that says don't bother checking the certificate online. You know the certificate is fine and there is no internet anyway, so skip the waiting game. With this change, your app launches fast again and your demo is back on track. In short, the app was slow because it kept trying to phone the internet for a security check it couldn't complete. Turning off the check solved the problem. We can see here, this is very good explanation. Now we can see the glossary. Okay, for example, when verify trust, a Windows function that verifies if a digital signature is trustworthy, including checking for certificate revocation online. .NET Frame, a set of tools and pre-made code for Microsoft that helps developers build apps. Think of it like a big toolbox for creating software. So we can see a lot of things. Code sign certificate. A digital signature proves an app is from a trusted source and hasn't been tampered with. It's like a seal of authenticity. Cryptography is the science of securing information using codes and locks. In this case, it's tied to managing the certificate security. So very good. We have seen this case also is a good case. Let's have another case. The slow project file open. Okay, here is a case where Microsoft project files stored on a network share were taking up to a minute to open and occasionally failed with an error. Let's see what process monitor found. We run the process monitor with the slow file opening. After capturing the trace, the file summary dialog in the process monitor tools file summary showed significant time spent in file operation on the network share. Let's see this option. We have file tool, file summary. So what is this? Let me try to see. Here we can see that we have, for example, this one. This is the time taken by this program. Okay, total events for this program. Opens, closes, reads, writes, read byte, write byte, get ACL, set ACL, others. So we can see, for example, this program have 234 open operation, close operation, read operation. There is no. So procmon, for example, this is the program. We have 386 events. This is the time taken for the program to, or the duration. We have 76 open, 70 close. We don't have anything. We have, so what this we can open it like that. I don't think it will do something. What this will do anyway. So let's see what this will do. If we go to this summary, the process monitor shows significant time spent in file operations on the, so he's talking or he's seeing the file time. Okay, this is like the duration, I think, that we have seen before. Okay, we have by folder, we have the operation by folder, by extension. So we have a lot of things. File access during trace, files accessed during trace. Okay, so these are the file accessed during our capture. Okay, we can see a lot of things anyway, so let's continue and see. The look at the file summary dialog, I see a pattern, many operation accessing files in the user app directory on the file server. If this is normal, operation accessing files in the user app directory on the file, that's normal. That's our first clue. The organization was using folder redirection to store user profiles, including app data on that server. This is a common practice, but it can cause performance issues for applications that frequently access those directories. That's correct. What's folder redirection? It's a feature that redirects folders like documents or app data to a server instead of storing them on a local computer. This is like, let me show you in simple terms. If we go and let me show you, if you go to the C, I have these are my profile folders, documents, download, music, pictures. All of these are stored in the C, users, Kareem. Okay, all of these are there. So these are redirected not to be saved locally on my PC in the C partition, to be saved to a server. Okay, so this is called file redirection or folder redirection. Okay, so this can slow down something. So if there is a program trying to access those folders frequently, this will delay because it will not access it locally. It needs to go to the server and access them remotely. What else did process monitor show? Let's look at specific operation taking the most time, the trace details. There are numerous small random reads to a file called global.mpt, which is a project template file, Microsoft project template file. Some reads are cached, but many are non-cached, forcing network round trips. What does cache versions, what does cached versus non-cached mean? When a file is read, Windows normally keeps a copy of the file a copy of the data in memory, the cache. If the program needs the same data again, it can get it from the memory instead of reading them from the disk or network. Cache reads are fast, non-cache reads are slow, especially over network. What's causing all of these reads? Let's check the call stack for these operations. They examine the call stack for one of the reads. The stacks show project itself making these reads, but there is also something called this file involved in some of them. Good catch. This file is semantic antivirus file system filter driver. It's scanning the files that are being accessed over the network. So this is an issue here. Semantic is scanning the files over the network. They examined the module so and so. The client had antivirus scanning enabled on the workstation, but the files were also being scanned by antivirus on the server. So it is scanned here and there. This duplicate scanning was causing significant delays. So the file was being scanned twice, yes, once on the server, once on the client. It's like having your bags checked by security twice at the airport, it doubles the wait time. What was the solution? Two recommendations. First, configure the roaming profile not to redirect app data and only sync it at login and log off. So this is thing. Second, set up exclusion filters in the client antivirus for the network shares hosting user profile. That's correct. Did that fix the issue? Yes. After implementing these changes, file open times were much faster and the occasional errors disappeared. So again, I will take it and ask Grok to explain it, even though it seems to be simple, but let me see also. This will be our last case with Godwill, so let's continue and take the last one. We have only uh, one try left. Okay, examine. Okay, let's do like this. Here you go. Okay, then we have copy, then put like that, and then put the case, copy, and then we can go and put it like this and then go like that and tell him explain that. Okay, we can filter this reset. Can close everything. Okay, let's do like this, do like that, like this again. So let me try to do something here. Let me try to read it out loudly. Okay, just to make it more simple. Where is the read out loud section? Okay.
Explanation in layman's terms. Imagine you're working on a big project using Microsoft Project, and your files are stored on a shared network drive. like a filing cabinet in another room that everyone in the office can use. Normally, opening a file should be quick, but in this case, it was taking up to a whole minute to load, and sometimes it even failed with an error. That's a huge hassle, right? Two tech experts, Leo and Maya, decided to figure out why this was happening and how to fix it. To solve the mystery, they used a tool called Process Monitor, which is like a detective's notebook that writes down every single thing the computer does, especially when it's trying to open those slow files. After recording what happened, they checked a section called the file summary, which showed that the computer was spending a lot of time dealing with files on the network share. Here's where they found the first clue. The computer was constantly accessing something called the app data folder, which was stored on the server instead of the local computer. App data is like a personal storage box where programs keep your settings and temporary files. In this company, they were using a trick called folder redirection, which means instead of keeping app data on your own computer, it's stored on the server. This is great for backups and for letting you use any computer in the office, but it's slower because the computer has to walk over the network to get those files instead of grabbing them from right next to you. Digging deeper, Leo and Maya noticed that Microsoft Project was making tons of tiny requests to a file called global.mpt, a template file it uses to set things up. Some of these requests were cached, meaning the computer had a copy ready in its memory, like having a photocopy on your desk, so those were fast. But a lot of them were non-cached, meaning it had to go back to the server every time, like walking to the filing cabinet again and again, which made everything super slow. Next, they looked at the call stacks. Think of these as a step-by-step map showing what the program was doing. They saw that Microsoft Project was the one asking for these files, but there was another player involved, something called srtsb64.sys. After some investigating, they figured out this was part of Symantec's antivirus software, a security guard checking files as they were opened. The problem? The company had antivirus turned on both on the server and on each person's computer. So every time a file was grabbed from a server, it got scanned there and again on the computer, like having your bag checked twice at the airport. This double checking was slowing everything down even more. So how do they fix it? Leo and Maya came up with two smart ideas. Stop redirecting app data. They suggested keeping app data on the local computer most of the time and only syncing it to the server when you log on or off. This way, the computer doesn't have to keep running to the server. It's like keeping your most used files on your desk instead of in another room. Tell the antivirus to chill. They recommended adding exclusion filters to the antivirus on the computers, so it wouldn't scan files coming from the network share. This stops the double scanning and cuts out unnecessary delays. After making these changes, the Microsoft Project files opened much faster, and those annoying errors went away. It's like finally being able to grab your papers quickly without waiting for two security checks.
So this is a good explanation, and I think we can stop at the case number 27, which is the compound case of Outlook hangs. So we will stop at this case and continue with God will in the upcoming video. Hope this video is informative to you all, and thank you all for viewing. Thank you so much.